from the depths of the ocean to the vast reaches of space, and even some quirky corners of everyday life, these incredible truths are guaranteed to make you question everything you thought you knew. So sit back, relax, and prepare to be amazed, because truth really is stranger than fiction.
Seahorses are marine creatures known for their unusual reproductive role reversal. Unlike most species, male seahorses carry and give birth to their young. This remarkable phenomenon occurs in all 46 recognized species of seahorses, making them one of the few animals where males experience pregnancy. The male seahorse has a specialized brood pouch located on its abdomen. During mating, the female deposits her eggs into this pouch through an ovipositor. The male then fertilizes the eggs internally, providing a safe and controlled environment for the developing embryos. The brood pouch regulates factors such as salinity and oxygen levels, mimicking natural sea conditions to ensure the embryo's survival. Depending on the species, male seahorses can carry anywhere from a few dozen to over 1,000 eggs at a time. The gestation period typically lasts between 10 and 25 days, influenced by environmental conditions like water temperature. When the young are ready to hatch, the male seahorse undergoes labor, which involves rhythmic contractions to release the fully formed baby seahorses, known as fry, into the water. This role reversal offers significant advantages for seahorse populations. By sharing the reproductive burden, males enable females to produce another clutch of eggs while the male is pregnant, potentially increasing reproductive output. This strategy also allows for better protection and care of the offspring, as the male can shield the developing embryos from predators and environmental stressors within the brood pouch. Male pregnancy in seahorses is a unique adaptation that underscores the diversity of reproductive strategies in the animal kingdom. It challenges traditional notions of gender roles in reproduction and provides scientists with valuable insights into evolutionary biology. The phenomenon also highlights the importance of conserving seahorse habitats, as their populations are threatened by overfishing, habitat loss, and the global aquarium trade. Seahorses are monogamous during the breeding season, often engaging in elaborate courtship rituals, including synchronized swimming and tail-curling displays. These behaviors not only strengthen pair bonds, but also play a role in the transfer of eggs during reproduction. In summary, the male seahorse's ability to carry and give birth to offspring is a fascinating example of nature's ingenuity, showcasing a role reversal that is as practical as it is extraordinary.
Cows are social animals with complex emotional and social structures, and research has revealed that they are capable of forming strong bonds with specific individuals within their herd. These close friendships, sometimes referred to as cow best friends, reflect the animal's need for companionship and their capacity for emotional depth. Studies have shown that cows prefer the company of certain herd mates and will spend more time grazing, resting, or grooming alongside their chosen companions. When cows are separated from their best friends, they exhibit clear signs of distress. This stress manifests in various ways, such as increased heart rates, vocalizations, and restlessness. Prolonged separation from their preferred companions can even lead to behavioral changes, such as reduced appetite or withdrawal, which can negatively affect their overall well-being. The ability of cows to form strong social bonds highlights their emotional intelligence and capacity for empathy. This knowledge has important implications for animal welfare, particularly in farming and husbandry practices. Providing cows with opportunities to maintain their preferred social bonds and minimizing stress-inducing separations can improve their quality of life and overall productivity. It also challenges the traditional view of cows as solely utilitarian animals, underscoring the importance of treating them with care and respect.
Elephants are often noted as being the only animals that cannot jump, a characteristic that sets them apart from most other land mammals. This inability is primarily due to their immense size and unique physical structure. Elephants can weigh between 2,000 and 14,000 pounds depending on the species, and their sheer mass makes jumping biomechanically impossible. Unlike smaller animals, elephants' legs are not designed for the rapid flexion and extension required to propel their bodies off the ground. Their legs function more like pillars, providing stability and support for their heavy bodies. Each leg is equipped with strong column-like bones that are positioned directly beneath their torso, allowing them to bear enormous weight while walking or standing. However, this arrangement limits the range of motion in their joints, particularly the ankles and knees, which are essential for jumping in other animals. Additionally, elephants lack the elastic tendons found in the hind limbs of jumping animals, such as kangaroos or frogs, which store and release energy during a jump. Interestingly, while elephants cannot jump, they are still incredibly agile for their size. They can walk, trot, and even run at speeds of up to 25 miles per hour, although their run is more of a fast shuffle. Despite this, at no point during their movement do all 4 feet leave the ground simultaneously, as would happen in a true jump. This unique trait also has evolutionary advantages. Elephants evolved to rely on their massive size and strength for protection rather than speed or agility. Their inability to jump is less a disadvantage and more a reflection of their specialized adaptations for a large, slow-moving herbivore lifestyle. Understanding this limitation emphasizes the remarkable ways in which animals are tailored to their environments and roles in the ecosystem.
Kangaroos are uniquely adapted for forward movement and are unable to walk backward, a limitation rooted in their anatomy and specialized method of locomotion. This characteristic is largely due to the structure of their hind legs and their large muscular tails, which are designed for hopping and balance rather than versatility in movement. A kangaroo's hind legs are incredibly powerful and highly adapted for their signature mode of locomotion, hopping or saltation. These legs move in tandem and the joints and muscles are optimized for generating forward propulsion. However, this design sacrifices the flexibility needed for backward movement. Kangaroos' legs cannot move independently in the way that most other quadrupedal animals can, further restricting their range of motion. The tail of a kangaroo also plays a significant role in preventing backward movement. It acts as a counterbalance during hopping and as a support when the kangaroo is stationary or moving slowly. When a kangaroo is standing, its tail rests on the ground, effectively blocking backward steps. The tail, combined with the unique alignment of their hind legs, makes it physically challenging for kangaroos to move in reverse. Interestingly, this limitation has minimal impact on a kangaroo's survival. Their forward-focused design is ideal for covering long distances efficiently and quickly, allowing them to escape predators and search for food in the vast Australian landscapes they inhabit. Their inability to walk backward is more of a quirk than a disadvantage, highlighting the specific adaptations that have enabled kangaroos to thrive in their environment. The fact that kangaroos can't walk backward is also why they are one of the 2 animals, along with the emu, featured on Australia's coat of arms. These animals symbolize progress and forward momentum, reflecting the national ethos of moving forward.
Penguins are well known for their adorable courtship behaviors, and one of the most endearing rituals involves presenting a pebble to a prospective mate. This behavior is most commonly observed in species like the Adelie and Gentoo penguins. The act of offering a pebble is symbolic, akin to a proposal, and plays a crucial role in the bonding process and nest building. For these penguins, pebbles are highly valued as they are used to construct nests that protect their eggs from cold ground and potential flooding. During courtship, a male penguin will search for the perfect pebble, smooth, clean, and of the right size, and present it to a female. If she accepts the pebble, it signifies that she is receptive to forming a pair bond. This mutual exchange fosters trust and solidifies their partnership for the breeding season, as many penguins are monogamous and will stay with the same mate for years. The process of finding the right pebble is no small task. In some colonies, pebbles can be scarce, leading to competition among males. Some penguins are even known to steal pebbles from other nests when resources are limited. However, the male's effort to find and present a pebble is a significant part of showing his dedication and suitability as a mate. This ritual highlights the importance of both practicality and affection in penguin relationships. While the pebble serves a functional purpose in nest building, The act of giving it is a tender gesture that demonstrates the male's commitment to the female and their future offspring. The behavior underscores the complex social and emotional lives of penguins, making them one of the most fascinating bird species in the animal kingdom.
A group of porcupines is charmingly called a prickle, a term that aptly describes their most distinctive feature, their quills. Porcupines are solitary animals for most of their lives, but they occasionally form small groups, particularly during mating season or in regions where food resources are concentrated. When they do gather, the term prickle humorously captures both their physical appearance and the potential danger posed by their sharp, spiny defenses. Porcupines are covered in quills, specialized hardened hairs coated with keratin, that serve as their primary defense mechanism. When threatened, porcupines can raise and rattle their quills to deter predators. Although they cannot shoot their quills as is often believed, the quills detach easily upon contact and can embed in an attacker, making the animal's collective presence in a prickle particularly intimidating. The social dynamics within a prickle vary by species. Some species, like the North American porcupine, are more solitary, while others, such as certain Old World porcupines, display more social tendencies and may den in small groups. In these cases, being part of a prickle offers advantages like shared warmth and protection from predators. The whimsical term prickle is a part of the broader tradition of unique and often poetic collective nouns for animal groups. It reflects human fascination with the natural world and our tendency to describe animal behaviors and traits in creative ways. While porcupines are not the most social creatures, the idea of a prickle of porcupines evokes both the humor and ingenuity of language, as well as the respect for the remarkable adaptations of these spiky mammals.
Axolotls, sometimes referred to as Mexican walking fish, are extraordinary amphibians known for their remarkable regenerative abilities. Native to lakes near Mexico City, axolotls have the unique capability to regrow lost body parts, including their limbs, spinal cord, heart, tail, and even sections of their brain. This ability sets them apart from most vertebrates and has made them a subject of fascination in scientific research. The regenerative process in axolotls is incredibly efficient and precise. When an axolotl loses a limb or suffers tissue damage, specialized cells near the injury site revert to a less specialized state resembling stem cells. These cells then proliferate and differentiate into the exact types of tissues needed to rebuild the lost structure. Unlike scar tissue formation in humans, the regenerated limb or organ in axolotls is fully functional and often indistinguishable from the original. Axolotls can regenerate more than just external body parts. They are capable of repairing internal organs, including their heart and lungs, and can even regenerate parts of their central nervous system. For example, if part of their spinal cord is damaged, they can restore its functionality, which is a feat unmatched in humans. Similarly, axolotls can regenerate sections of their brain, offering a glimpse into their astonishing neuroplasticity. This regenerative ability has significant implications for science and medicine. Researchers study axolotls to better understand the cellular and molecular mechanisms underlying regeneration, hoping to apply these findings to human medicine. Insights from axolotl research could pave the way for advancements in treating spinal cord injuries, degenerative diseases, and organ damage. The axolotl's regeneration is not just a scientific marvel, but also a critical survival trait in their natural habitat. As a predator and prey species, their ability to recover from injuries enhances their resilience in the wild. However, despite their unique abilities, axolotls are critically endangered in their native environment due to habitat loss and pollution. Conservation efforts aim to protect these incredible creatures and ensure their survival both in the wild and as a vital resource for scientific discovery.
Starfish, or sea stars, have a fascinating and highly specialized feeding mechanism that allows them to turn their stomachs inside out to consume their prey. This unique adaptation is primarily used to feed on bivalve mollusks, such as clams and mussels, which are otherwise difficult to access due to their hard shells. The feeding process begins when a starfish uses its strong tube-like feet, powered by a water vascular system, to pry open the shell of its prey, creating a small gap. Once the shell is slightly ajar, the starfish everts its stomach, pushing it out through its mouth and into the prey's shell. This external stomach then releases digestive enzymes to break down the soft tissues of the prey, effectively liquefying it. The starfish absorbs the nutrients directly through its stomach lining, after which it retracts the stomach back into its body. This ability to evert its stomach allows the starfish to consume prey much larger than what its small central mouth would otherwise accommodate. It also minimizes the need for strong, crushing jaws, a feature many other predators rely on. The process is highly efficient and enables the starfish to thrive in environments where other predators might struggle to access similar food sources. Starfish play a crucial role in marine ecosystems as both predators and prey. By feeding on bivalves and other invertebrates, they help maintain the balance of these populations, preventing overgrowth that could disrupt the ecosystem. Their remarkable feeding mechanism underscores their evolutionary success and adaptability. This behavior is not only a marvel of biology, but also a reminder of the diversity and ingenuity of life in the ocean. The ability to turn their stomachs inside out showcases how starfish have evolved highly specialized traits to survive and thrive in their unique ecological niches.
Horses are unique among mammals in that they cannot vomit, a limitation rooted in their anatomy and physiology. This inability is due to the structure of their digestive system, particularly the powerful lower esophageal sphincter, also known as the cardiac sphincter. This muscular valve connects the esophagus to the stomach and is designed to prevent food and stomach acid from flowing backward. In horses, the lower esophageal sphincter is exceptionally strong and one-way, meaning it effectively seals the stomach once food enters, preventing regurgitation or vomiting. Additionally, a horse's stomach is relatively small and positioned deep within the rib cage, making the mechanics of vomiting nearly impossible. The angle at which the esophagus connects to the stomach further reinforces this one-way system. Unlike in other animals, the stomach muscles in horses are not designed to contract forcefully in reverse, which is necessary for vomiting. While this design helps prevent aspiration of stomach contents and allows horses to graze continuously without risk of reflux, it also presents significant risks. If a horse ingests something toxic, develops a gastrointestinal blockage, or suffers from severe colic, it cannot relieve the pressure or expel harmful substances by vomiting. This inability can lead to serious complications, such as stomach rupture, which is often fatal. Because horses cannot vomit, their digestive health requires careful management. Horse owners must ensure their animals have access to appropriate feed, avoid sudden dietary changes, and monitor for signs of colic or discomfort. Preventative care, such as regular dental checkups and deworming, also plays a vital role in maintaining their well-being. The horse's inability to vomit is an evolutionary adaptation that reflects its grazing lifestyle. However, it also underscores the importance of responsible care to minimize the risks associated with this anatomical limitation.
Ants are remarkable creatures with fascinating behaviors, and one of their lesser-known habits is their tendency to stretch and yawn when they wake up. While these actions might resemble human stretching and yawning, they are better understood as part of the ants' natural way of preparing their bodies for activity after a period of rest. Ants, like most insects, operate on a cyclical rhythm of activity and rest. During their rest periods, which are short and frequent rather than prolonged like human sleep, their bodies enter a state of reduced activity to conserve energy. These movements may involve extending their legs and antennae, which could serve multiple purposes, reactivating their muscles, enhancing their sensory perception, and ensuring their limbs and appendages are fully functional for the tasks ahead. The yawning behavior sometimes observed in ants is not a true yawn in the human sense, as ants do not breathe through their mouths. Instead, it is likely an opening and closing of their mandibles, possibly to clean or realign them, or to prepare for communication or foraging. Ants rely heavily on their mandibles for various activities, including feeding, carrying objects, and defending their colony, so ensuring their readiness is crucial. These behaviors are part of the ants' efficient and highly organized approach to colony life. Each individual ant plays a specific role, and even seemingly small actions like stretching and yawning contribute to their ability to perform tasks effectively. Observing these behaviors provides insight into how ants maintain their physical readiness and adapt to their demanding cooperative lifestyles. While these behaviors may seem simple, they underscore the complexity and adaptability of ants as social insects. Their ability to prepare themselves physically for activity after rest reflects the intricate balance of work and rest required to sustain the colony's productivity and survival.
The oldest known "your mum" joke dates back over 3,500 years to ancient Babylon, proving that humour rooted in playful insults has been a part of human culture for millennia. This joke is recorded on a tablet discovered in Iraq and is part of a collection of riddles and proverbs written in the Akkadian language, the lingua franca of the time. The tablet, dated to around 1500 BCE, is incomplete and heavily eroded, but enough survives to identify it as a humorous quip. The joke, as reconstructed by scholars, is an example of a yo mama insult. While the full context and exact wording have been lost due to the tablet's condition, the structure indicates it was meant to tease or provoke laughter, likely in a social or communal setting. The existence of this joke highlights how humour, especially of the irreverent and teasing variety, transcends time and cultural boundaries. It also provides insight into the everyday lives of ancient Mesopotamians, showing that humour was as integral to their lives as it is to ours today. This discovery is significant not only for its comedic value, but also for what it reveals about the continuity of human expression. The use of familial relationships as a basis for humour underscores a universal trait, the ability to laugh at shared social experiences. Even thousands of years ago, people found amusement in the playful and exaggerated lampooning of common subjects, such as family dynamics. Though the specifics of this Babylonian joke might be obscure, its existence as the oldest recorded "your mum" joke connects us to our distant ancestors in a surprisingly relatable way. It reminds us that while civilizations rise and fall, certain aspects of human nature, like humour, remain remarkably consistent.
The shortest war in recorded history took place on August 27, 1896, between the British Empire and the Sultanate of Zanzibar. This conflict, known as the Anglo-Zanzibar War, lasted a mere 38 minutes from the start of hostilities to the surrender of Zanzibar. The war arose due to a succession crisis in Zanzibar and the enforcement of British imperial interests in the region. Zanzibar, a small island off the coast of East Africa, was a strategically important territory for trade and British influence in the late 19th century. In 1890, the British and Germans signed the Heligoland-Zanzibar Treaty, making Zanzibar a British protectorate. When Sultan Hamad bin Thuwaini, a British ally, died suddenly on August 25, 1896, his successor, Sultan Khalid bin Bargash, took power without British approval. Khalid was perceived as hostile to British interests, particularly regarding their stance against the slave trade, which he supported. The British demanded that Khalid abdicate and proposed a more cooperative leader, Hamoud bin Muhammad, as the new sultan. Khalid refused and fortified the palace with his supporters and artillery, setting the stage for conflict. At 9:02 a.m. on August 27, 1896, after the expiry of an ultimatum given to Khalid, British warships in the harbour opened fire on the palace. The bombardment was devastating. Within minutes, most of Khalid's defences were destroyed, and the palace suffered significant damage. Zanzibari forces, numbering around 2,800, were outmatched by the superior firepower of the British fleet. By 9:40 a.m., Khalid's forces had surrendered, marking the end of the war. Zanzibari casualties were reported to be around 500, while the British sustained only one minor injury. Sultan Khalid fled to the German consulate, where he was given asylum. He was later captured and exiled, while the British installed Sultan Hamoud bin Muhammad as their preferred ruler. The war solidified British control over Zanzibar and demonstrated the might of British naval power during the height of its empire. It also served as a stark example of the disparity in military technology and organization between colonial powers and smaller states. Sultan Hamud, the new ruler, complied with British demands, including the abolition of the slave trade. The Anglo-Zanzibar War is remembered not only for its brevity, but also as a symbol of the imperial dominance of the British Empire. It highlights the rapid and often overwhelming force used by colonial powers to maintain control over their territories. Despite its short duration, the war is a fascinating historical footnote, illustrating the dynamics of imperialism, local resistance, and geopolitical maneuvering in the late 19th century.
Genghis Khan's conquests in the 13th century were so devastating that they had an unintended environmental impact. They temporarily reduced global carbon dioxide levels. This phenomenon, often called the Genghis Khan effect, occurred because the Mongol invasions caused widespread destruction, depopulation, and the abandonment of agricultural land, leading to large-scale reforestation and the absorption of carbon dioxide from the atmosphere. Genghis Khan, who lived from 1162 to 1227, was the founder of the Mongol Empire. He led a series of campaigns that created the largest contiguous empire in history, stretching from East Asia to Eastern Europe. These conquests resulted in the deaths of an estimated 40 million people, or about 10% of the world's population at the time. Entire cities and civilizations were razed, and agricultural systems were disrupted across vast regions. The mass depopulation caused by the Mongol invasions had significant ecological consequences. With fewer people to tend farmland, vast tracts of cultivated land were abandoned and reverted to natural forests. This reforestation acted as a carbon sink, absorbing large amounts of carbon dioxide from the atmosphere. Researchers estimate that up to 700 million tons of carbon dioxide were removed during this period, an amount roughly equivalent to a year's worth of global gasoline consumption today. Forests play a crucial role in regulating the Earth's carbon cycle. When farmland is abandoned, natural vegetation regenerates and forests absorb carbon dioxide through photosynthesis. The reforested areas that emerged after the Mongol invasions likely covered millions of acres, especially in parts of Asia and Europe. This reduction in atmospheric carbon dioxide likely contributed to a slight cooling of the Earth's climate, though other factors such as volcanic activity and solar variations also influence medieval climate patterns. This phenomenon is one of several instances in history where human activity, or its cessation, has influenced the Earth's carbon balance. Other examples include the depopulation of the Americas following European colonization and the subsequent reforestation, as well as industrial deforestation in more recent centuries. The Genghis Khan effect is unique in that it underscores the unintended environmental impact of large-scale violence and conquest. While the temporary cooling effect caused by the Mongol Empire's conquests may seem like a historical footnote, it highlights the interconnectedness of human activity and the environment. It serves as a stark reminder of how societal collapses, whether due to war, disease, or other factors, can have lasting ecological effects. The Mongol Empire's conquest left a legacy not only in terms of geopolitics and culture, but also in the planet's ecological history.
The first oranges weren't orange, they were green. This surprising fact highlights the diversity of citrus fruits and their adaptations to different climates. Oranges, specifically the original sweet varieties, originated in Southeast Asia, particularly in regions such as modern-day India, Vietnam and southern China. These early oranges were likely green when ripe, a trait that persists in certain climates to this day. The color of an orange's peel depends on its environment, particularly temperature. In tropical and subtropical climates, oranges often remain green when ripe because the constant warmth prevents the breakdown of chlorophyll in the peel. Chlorophyll is the pigment that gives plants their green color. In cooler climates, however, the lower temperatures during ripening trigger the breakdown of chlorophyll, allowing the orange carotenoid pigments to dominate and giving the fruit its characteristic bright orange colour. The first oranges, varieties like the pomelo and mandarin, which are the ancestors of modern sweet oranges, developed in consistently warm climates where the green colour persisted even at full ripeness. Even today, green oranges are common in tropical regions such as Thailand, Vietnam and parts of Central America. These oranges are fully ripe and just as sweet as their orange-coloured counterparts. In fact, in these regions, an orange peel's colour is not considered an indicator of ripeness. Consumers judge ripeness by other factors, such as the fruit's aroma and texture. In contrast, oranges grown in temperate regions, such as the United States and parts of Europe, turn orange due to cooler autumn and winter temperatures. In some cases, producers in tropical areas artificially remove the green coloration by exposing the fruit to ethylene gas or refrigerating it to mimic cooler climates, making them more appealing to markets where consumers expect oranges to be, well, orange. The green to orange transformation also has cultural and linguistic implications. The English word orange comes from the Old French term orange, which itself was derived from the Sanskrit word naranga through Persian and Arabic. This linguistic journey reflects the fruit's movement along ancient trade routes, but the association of the word with the colour only became solidified in Europe, where oranges ripened to a vivid orange hue. Understanding the history of green oranges provides insight into the evolution of agriculture, trade and human preferences. It also underscores the importance of climate and environment in shaping the characteristics of crops. While most of us are accustomed to bright orange fruits, green oranges serve as a reminder of the rich variety within nature and the adaptability of plants to their surroundings.
After Albert Einstein's death on April 18, 1955, his brain was removed without permission, setting off a decades-long saga of controversy and scientific inquiry. Einstein, one of history's most renowned physicists, had revolutionized our understanding of the universe with his theories of relativity. His intellect fascinated scientists and the public alike, and this fascination extended beyond his life, leading to the illicit preservation and study of his brain. Einstein died of an abdominal aortic aneurysm in Princeton, New Jersey at the age of 76. During his autopsy, conducted by pathologist Dr. Thomas Harvey at Princeton Hospital, Harvey removed Einstein's brain without the permission of his family. Harvey reportedly justified this act by claiming it was for scientific research, believing that studying the brain of such a brilliant mind could unlock the secrets of genius. Einstein had explicitly stated in his will that he wanted to be cremated and his remains scattered, and he made no mention of donating his brain to science. Despite this, Harvey took the brain, along with Einstein's eyes, which were given to Einstein's ophthalmologist. Harvey preserved Einstein's brain in formalin and divided it into 240 blocks. He also made over 1,000 microscopic slides of brain tissue for analysis. He kept these samples for decades, distributing them to researchers worldwide for study. Over the years, various scientists examined the brain, hoping to uncover physical correlates of Einstein's exceptional intellect. Some studies claim to find differences in Einstein's brain structure. For example, in 1985, a study suggested that Einstein had an unusually high number of glial cells, which support and nourish neurons in certain parts of his brain. In 1999, researchers reported that his parietal lobes, associated with spatial reasoning and mathematical ability, were unusually large and lacked a typical groove, potentially enhancing connectivity. These findings were widely publicized but remain controversial. Critics argue that the studies were poorly controlled and relied on limited anecdotal comparisons. Moreover, the ethics of studying Einstein's brain, removed and preserved without his consent, cast a shadow over the entire endeavor. The unauthorized removal of Einstein's brain had significant consequences for Dr. Harvey. After Einstein's family learned about the incident, his son Hans Albert Einstein was initially furious, but eventually granted Harvey permission to keep the brain, provided it was used only for scientific research. However, Harvey's career suffered. He lost his job at Princeton Hospital and spent the rest of his life moving from place to place, taking Einstein's brain with him. Harvey eventually returned the remaining pieces of the brain to Princeton Hospital in 1998. Today, some of these samples are stored at the Mutter Museum in Philadelphia, where they are occasionally displayed. The story of Einstein's brain raises profound ethical questions about consent, privacy, and the treatment of human remains. While the studies conducted on his brain have yielded intriguing insights, they have not provided definitive answers about the biological basis of genius. Einstein's legacy as a physicist and humanitarian far overshadows the controversy surrounding his brain, but the episode serves as a cautionary tale about the boundaries of scientific curiosity and respect for individual autonomy.
In the summer of 1518, the city of Strasbourg, then part of the Holy Roman Empire, now in modern-day France, was gripped by a bizarre and inexplicable event known as the Dancing Plague. Over the course of several weeks, dozens of people were afflicted with an uncontrollable compulsion to dance, sometimes to the point of exhaustion or death. This phenomenon remains one of the most mysterious mass hysteria events in history. The Dancing Plague began in July 1518 when a woman named Frau Trophea stepped into the streets of Strasbourg and began to dance fervently. She appeared unable to stop, continuing for hours and then days. Within a week, her strange behavior had attracted dozens of others who joined her in a similarly uncontrollable dance. Reports suggest that as many as 400 people eventually became part of the epidemic. The dancers were not performing joyful or celebratory movements. They seemed to be in a trance-like state, moving erratically and sometimes crying or screaming. Many of them collapsed from exhaustion, and some reportedly died from heart attacks, strokes, or sheer fatigue. The cause of the dancing plague has baffled historians and scientists for centuries. Several theories have been proposed, including 1. Mass hysteria. The most widely accepted explanation is that the dancing plague was a case of mass psychogenic illness triggered by stress and fear. Strasbourg in 1518 was a time of hardship, marked by famine, disease, and economic instability. These pressures may have caused a collective psychological breakdown, manifesting as a hysterical dancing frenzy. 2. Ergot poisoning. Another theory posits that the afflicted individuals consume bread contaminated with ergot, a fungus that grows on damp rye and can produce hallucinations, convulsions, and other symptoms similar to those seen during the dancing plague. Ergot poisoning has been linked to other historical events, but it does not fully explain the prolonged and coordinated nature of the dancing. 3. Religious or superstitious beliefs. Some historians suggest that the event may have been linked to local religious beliefs. Saint Vitus, the patron saint of dancers, was believed to have the power to curse people with uncontrollable dancing. Fear of divine punishment could have played a role in the outbreak. 4. Social contagion. In tightly knit communities, behaviors can spread rapidly through imitation and suggestion. In a time of heightened stress and fear, witnessing others dance uncontrollably may have triggered similar responses in susceptible individuals. The local authorities initially believed that the afflicted could dance off their condition. They even hired musicians and built stages to facilitate the dancing, hoping it would bring about a cure. This strategy backfired as it seemed to exacerbate the problem, drawing more people into the frenzy. Eventually they turned to religious intervention, organizing prayers and processions to St. Vitus, and the epidemic subsided by September 1518. The dancing plague of 1518 is one of the most documented cases of a phenomenon known as dance mania, which was reported sporadically in Europe from the 14th to the 17th centuries. It remains an enduring mystery and a fascinating example of how psychological, social, and cultural factors can intersect to produce extraordinary collective behavior. The event also serves as a reminder of the power of societal stress and the human mind's capacity to manifest distress in physical and communal ways. While no definitive explanation exists, the dancing plague continues to capture the imagination of historians, psychologists, and artists alike.
The claim that Pope Gregory IV declared a war on cats in the 13th century is a popular anecdote, but it is not entirely accurate when viewed in historical context. The story stems from a papal decree or belief associated with Pope Gregory IV that linked cats, particularly black cats, with heresy and devil worship. This belief contributed to broader medieval superstitions, associating animals with witchcraft and the occult. In 1233, Pope Gregory VI, not Gregory IV, issued the Vox in Rama, a papal bull addressing the spread of heresy, specifically concerning a cult alleged to practice satanic rituals. The bull described ceremonies where a black cat was reportedly involved as a demonic symbol, further fueling anti-cat sentiment in the Christian world. The bull was part of broader measures to combat heretical movements in Europe, particularly in Germany. While Pope Gregory IX's text does not call for the extermination of cats explicitly, its content contributed to widespread suspicion of cats as accomplices in witchcraft. Over time, these ideas contributed to the persecution and killing of cats, especially black ones, across Europe. Cats were believed to be familiars of witches or even embodiments of the devil, leading to their association with evil. This superstitious fear culminated in mass culling of cats in various regions during the Middle Ages. Some historians suggest that the mass killing of cats may have had unintended consequences, such as enabling a rise in rodent populations, which could have exacerbated the spread of the Black Death in the 14th century. However, this connection remains speculative, as the plague's primary transmission vectors were fleas on rats, and the dynamics of disease transmission are complex. While Pope Gregory IX's Vox in Rama had significant cultural impacts, it is important to approach the story critically and recognize that the war on cats narrative has been exaggerated and simplified over time. It reflects a mixture of historical events, medieval superstitions, and later interpretations, rather than a straightforward declaration of a campaign against cats by the Church.
The Great Emu War of 1932 was a bizarre and often humorously recounted event in Australian history, in which the Australian military attempted to curb the population of emus, large, flightless birds native to the continent. This war occurred in the state of Western Australia and ended with the emus emerging as the clear victors, much to the embarrassment of the military forces involved. The conflict arose during a challenging period of Australian history, the Great Depression. Many unemployed veterans from World War I had been granted land in Western Australia for farming. However, these farmers faced significant hardships, including drought, low crop prices, and most notably, an invasion of emus. Around 20,000 emus migrated from inland regions to the agricultural areas, damaging crops and causing financial ruin for many farmers. In response to the farmers' pleas for assistance, the Australian government decided to intervene. Major GPW Meredith of the Royal Australian Artillery was dispatched with a small military force, equipped with 2 Lewis machine guns and 10,000 rounds of ammunition to address the emu problem. The campaign began in November 1932, but the emus quickly proved to be formidable opponents. The birds demonstrated remarkable speed, agility, and group cohesion, making them difficult targets. They traveled in large flocks, but often scattered in unpredictable directions when approached. The military faced numerous logistical challenges, including difficulties in maneuvering the heavy machine guns and hitting the fast-moving emus. One of the most infamous moments occurred when the soldiers attempted to ambush a group of emus near a dam. Despite firing on the birds, only a few were killed, and the rest scattered into the surrounding countryside. On another occasion, the military mounted a gun on a truck to chase the emus, but the rough terrain rendered the operation ineffective. After several weeks of effort, the operation was deemed a failure. Major Meredith's team had killed approximately 1,000 emus, far fewer than expected, and had expended a significant amount of ammunition. The emus, on the other hand, continued to roam the farmland largely unscathed, earning the unofficial victory in what became known as the Great Emu War. The Great Emu War highlighted the futility of using military tactics against nature and became a symbol of human ineptitude in the face of wildlife. The Australian government abandoned military interventions and later encouraged farmers to manage the emu population with fencing and other measures. Additionally, a bounty system was introduced, which proved more effective in controlling the birds. The event has since become a humorous anecdote and is often cited as an example of nature triumphing over human attempts at control. It remains a quirky and endearing chapter in Australian history, capturing the imagination of people worldwide.
The Leaning Tower of Pisa is one of the most famous architectural landmarks in the world, renowned for its unintended tilt. Construction of this iconic structure spanned 344 years, beginning in 1173 and concluding in 1319 for the main structure, with final completion, including the bell chamber in 1372. Its long construction period is a testament to the challenges posed by its unstable foundation and the technological limitations of the time. The tower was designed as a freestanding bell tower, or campanile, for the adjacent Pisa Cathedral, part of the city's Campo dei Miracoli, or Field of Miracles. The project began in 1173 under architect Bernardo Pisano, though his involvement remains debated. The first phase of construction lasted until 1178, when workers had completed the first 3 stories. During this early phase, the foundation began to sink due to the unstable subsoil composed of clay, sand and silt. This caused the tower to tilt noticeably to the south. Construction was halted not only due to the tilt, but also because of ongoing wars between Pisa and neighbouring city-states such as Florence and Genoa. This pause lasted nearly a century and ironically helped the tower survive, as the soil had time to settle. When construction resumed in 1272 under architect Giovanni di Simone, efforts were made to correct the tilt. Builders attempted to compensate by constructing the upper stories with one side taller than the other. This gave the tower its characteristic curved appearance as successive levels were adjusted to counteract the lean. However, the tilt continued to worsen as construction progressed. The main structure was completed in 1319, but the final addition, the bell chamber, was only added in 1372 by architect Tommaso di Andrea Pisano. The total time from the start to finish, considering interruptions, amounted to 344 years. The tilt of the Leaning Tower of Pisa became its defining characteristic and a source of fascination. Over the centuries, the lean gradually worsened, reaching a dangerous angle of 5.5 degrees by the 20th century. Efforts to stabilize the structure began in earnest in the late 20th century. Engineers employed innovative techniques, including soil extraction and counterweights, to reduce the tilt to a safer angle of about 4 degrees by 2001. The tower reopened to the public in 2001 after a decade-long stabilization project. The Leaning Tower of Pisa stands as a symbol of architectural ambition and resilience. Its unintended tilt has made it a global icon, drawing millions of tourists annually. It is a UNESCO World Heritage Site, celebrated for its historical and architectural significance alongside the cathedral and baptistry in the Field of Miracles. The tower's prolonged construction period and its subsequent lean serve as reminders of the complexities of medieval engineering and the unpredictable challenges of working with natural landscapes. Far from being a failure, the Leaning Tower of Pisa has become a triumph of preservation and a beloved emblem of human ingenuity.
The idea that people in the Victorian era sent letters using hollowed-out potatoes is a curious anecdote that captures the imagination, but it is more of a whimsical myth than a well-documented historical practice. While the Victorian era, from 1837 to 1901, was indeed a time of significant postal innovation, including the introduction of the penny post in 1840. The practice of sending unconventional items through the mail was generally rare and often limited by practicality and postal regulations. The Victorian period revolutionized mail delivery with advancements like affordable postage, the standardization of mailboxes, and the introduction of postmarks. The penny post allowed people to send letters anywhere within Britain for a penny, leading to a massive increase in correspondence. This era also saw the rise of the postcard, which became a popular and inexpensive way to send short messages. The idea of sending hollowed-out potatoes as a means of delivering letters seems to be more of a playful anecdote than a widespread historical practice. While it's not entirely implausible that someone might have attempted such a thing as a prank or novelty, there is no substantial evidence to suggest it was common or practical during the Victorian era. Sending a hollowed-out potato as a letter would have faced several obstacles. Potatoes are perishable and bulky, making them impractical for reliable delivery. Additionally, postal regulations of the time required items to be securely packaged and clearly addressed. While Victorian postmasters might have handled a variety of unusual items, it is unlikely they would have tolerated hollowed-out vegetables on a regular basis. The myth of potato mail fits within a broader fascination with quirky Victorian customs, many of which have been exaggerated or invented over time. The era's sense of humour, combined with the popularity of novelty items and elaborate practical jokes, may have contributed to the persistence of this story. While the story of Victorians sending letters in hollowed-out potatoes is entertaining, it is more likely a myth than a reflection of historical postal practices. The Victorian era was indeed a time of postal creativity, but its innovations were more focused on efficiency and accessibility than on vegetable-based correspondence.
The statement that all the planets in the solar system can fit side by side between Earth and the Moon is a fascinating astronomical fact, and it highlights the vastness of space even within our own celestial neighborhood. Here's how this works. The average distance between Earth and the Moon is about 384,400 kilometers, or 238,855 miles. This measurement, known as the lunar distance, varies slightly due to the Moon's elliptical orbit, but it is sufficient for this calculation. If we add up the equatorial diameters of all the planets in the solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, the total comes to approximately 364,900 kilometers, or 226,000 miles. Here's the breakdown. Mercury, 4,880 kilometers. Venus, 12,104 kilometers. Earth, 12,742 kilometers. Mars, 6,779 kilometers. Jupiter, 139,820 kilometers. Saturn, 116,460 kilometers. Uranus, 50,724 kilometers. Neptune, 49,244 kilometers. When these diameters are summed up, the total is slightly less than the average Earth-Moon distance, leaving some extra room even after accounting for all the planets lined up. The reason this fact is so surprising is due to the vast difference between planetary sizes and the immense distances in space. While planets like Jupiter and Saturn are massive compared to Earth, their diameters are minuscule when measured against the distances between celestial bodies. This serves as a reminder of the scale of the universe and how far apart objects in space truly are. This comparison is purely theoretical, since planets cannot align in a straight line in real life, let alone line up between Earth and the Moon. However, the fact serves as a thought-provoking exercise in understanding spatial relationships within our solar system and the surprising emptiness of space. The idea that all the planets could fit side by side between Earth and the Moon is a striking demonstration of the relative sizes and distances in our solar system. It's a testament to the vastness of space, even in what we often perceive as a relatively small part of the universe. This thought experiment not only fuels curiosity about astronomy, but also underscores the remarkable scales at play in our cosmic neighborhood.
The Mpemba effect is the counterintuitive phenomenon where, under certain conditions, hot water freezes faster than cold water. This effect has puzzled scientists and observers for centuries and remains a topic of ongoing debate and study in the field of physics. Named after Erasto Mpemba, a Tanzanian student who popularized it in the 1960s, the effect challenges our understanding of heat transfer and thermodynamics. The Mpemba effect has been noted by scholars throughout history. Aristotle in ancient Greece, Francis Bacon in the 17th century, and René Descartes all documented similar observations. However, the phenomenon was not rigorously studied until Mpemba, a high school student, observed that warm ice cream mix froze faster than a cold mix when placed in the freezer. This observation led to scientific investigations into the effect, which has since been named in his honor. Despite extensive research, the Mpemba effect is not fully understood and no single explanation has been universally accepted. Several hypotheses have been proposed, including 1. Evaporation. Hot water evaporates more quickly, reducing the volume of water that needs to freeze. This smaller volume may freeze faster than the larger volume of cold water. 2. Convection currents. Hot water may develop convection currents that accelerate the cooling process by distributing heat more evenly compared to cold water. 3. Dissolved gases. Hot water tends to release dissolved gases, which might alter its freezing point or thermal conductivity. 4. Supercooling differences. Cold water might supercool, dropping below its freezing point without solidifying more easily than hot water, delaying the freezing process. 5. Thermal conductivity of the container. The interaction between the water and the container might differ based on the initial temperature, influencing heat transfer rates. 6. Hydrogen bond dynamics. Some researchers have suggested that differences in hydrogen bonding and molecular structure between hot and cold water may play a role in the Mpemba effect. It's important to note that the Mpemba effect is not always observed. The phenomenon depends on various factors, including the initial temperatures of the water, the cooling environment, the type of container used, and the presence of impurities or dissolved gases in the water. Under certain conditions, cold water may freeze faster than hot water, as one would intuitively expect. The Mpemba effect remains controversial, with some scientists questioning whether it exists as a distinct phenomenon or if it is the result of specific experimental setups. Experimental results have been inconsistent, partly due to the difficulty of precisely controlling all variables. Recent studies using advanced techniques have added to the complexity of the discussion rather than resolving it. While the Mpemba effect is primarily a topic of scientific curiosity, understanding it could have practical implications for fields like cryogenics, refrigeration, and materials science. However, its real-world applications remain limited until a definitive explanation is found. The Mpemba effect is a fascinating reminder that nature often defies simple expectations. Though it challenges our understanding of basic principles like heat transfer, it also highlights the complexity of seemingly straightforward phenomena. The ongoing investigation into the effect underscores the importance of curiosity and observation in scientific discovery.
HD 189733b is one of the most extreme and fascinating exoplanets ever discovered. Located about 64.5 light-years from Earth in the constellation Vulpecula, this hot Jupiter is infamous for its hellish weather, which includes sideways rain of molten glass, due to ferocious winds and scorching temperatures. It serves as a vivid example of how alien and inhospitable worlds beyond our solar system can be. HD 189733b was discovered in 2005 using the transit method, where astronomers observe the dimming of a star's light caused by a planet passing in front of it. The planet is a gas giant similar in size to Jupiter, but it orbits its host star at an extremely close distance, just 4.7 million kilometers or 2.9 million miles. This proximity makes it a hot Jupiter, a class of exoplanets characterized by high temperatures and rapid orbits. HD 189733b completes one orbit around its star in just 2.2 Earth days. What makes HD 189733b particularly intriguing is its violent and bizarre weather, molten glass rain. The planet's atmosphere contains silicate particles, which condense into tiny glass droplets under extreme heat. These droplets form in the upper atmosphere and are carried by relentless winds. The glass rain reflects blue light, giving the planet a striking blue appearance when observed from a distance. Supersonic winds. Winds on HD 189733b reach speeds of up to 8,700 kilometers per hour or 5,400 miles per hour. These winds are so strong that they carry the molten glass rain sideways, making the weather even more extreme and chaotic. The planet's proximity to its host star results in surface temperatures of approximately 1,000 degrees Celsius or 1,832 degrees Fahrenheit. This intense heat drives the violent weather patterns and prevents the planet from being hospitable to any form of life as we know it. HD 189733b has been extensively studied using telescopes like the Hubble Space Telescope and the Spitzer Space Telescope. Observations of its atmosphere have provided valuable insights into the composition and behavior of exoplanetary atmospheres. For example, scientists have detected water vapor, methane and carbon monoxide in its atmosphere, along with the silicate particles responsible for the glass rain. The planet's vivid blue color, observed in 2013, contrasts with Earth's blue appearance, which is due to Rayleigh scattering in our atmosphere. On HD 189733b, the blue hue is caused by the reflective properties of the molten glass droplets. Despite significant advancements in exoplanet research, studying HD 189733b remains challenging due to its distance and the limitations of current technology. The extreme conditions on the planet also push the boundaries of atmospheric modelling and highlight the diversity of planetary systems in the universe. HD 189733b is a prime example of the extreme environments that exist beyond our solar system. Its study helps astronomers better understand the diversity of exoplanets and their weather systems, which in turn informs our search for habitable worlds and extraterrestrial life. HD 189733b is a mesmerizing and terrifying example of an alien world with weather unlike anything on Earth. From its sideways rain of molten glass to its supersonic winds and scorching heat, it offers a glimpse into the incredible variety of planets in the cosmos. Studying such extreme exoplanets not only deepens our understanding of planetary science, but also underscores the uniqueness of Earth as a haven for life.
Mercury, the smallest planet in our solar system and the one closest to the Sun, has a remarkably short year, just 88 Earth days. This means that Mercury completes an orbit around the Sun in less than 3 Earth months. The planet's short year is a result of its close proximity to the Sun and its rapid orbital speed, making it a fascinating subject of study in planetary science. Mercury orbits the Sun at an average distance of about 58 million kilometers, or 36 million miles, much closer than Earth's 149 million kilometers, or 93 million miles. Being so close to the Sun, Mercury experiences a much stronger gravitational pull, which accelerates its orbital speed to an impressive 47 kilometers per second, or 29 miles per second. This high speed allows Mercury to complete a full revolution around the Sun in just 88 Earth days, earning it the title of having the shortest year in the solar system. While a year on Mercury is short, its day, the time it takes for the planet to complete one rotation on its axis, is surprisingly long. Mercury rotates very slowly, taking about 59 Earth days to complete one rotation. This means that a single day on Mercury lasts nearly 2/3 of its year. This slow rotation creates a unique dynamic where, during certain periods, an observer on Mercury would see the sun rise, pause, reverse slightly, and then continue its path across the sky. Mercury's short year and proximity to the sun contribute to its extreme temperature variations. The planet lacks a substantial atmosphere to retain heat, so temperatures on its surface can range from a scorching 430 degrees Celsius, or 800 degrees Fahrenheit, during the day to a freezing -180 degrees Celsius, or -290 degrees Fahrenheit, at night. These extreme conditions make Mercury one of the most inhospitable places in the solar system. Mercury's short year and unique rotation have made it a key focus for scientific exploration. Missions like NASA's Messenger and the ongoing European-Japanese Bepi-Colombo mission have provided valuable insights into Mercury's geology, magnetic field, and atmosphere. Understanding Mercury's orbit and rotational dynamics also helps scientists refine their models of planetary formation and evolution. If you lived on Mercury, you would celebrate a birthday every 88 Earth days, making you considerably older in Mercury years than you are in Earth years. However, with its long days, you'd also experience fewer sunrises and sunsets relative to the number of years that pass. A year on Mercury, lasting only 88 days, is a remarkable consequence of its closeness to the Sun and its rapid orbital speed. This feature, combined with its slow rotation and extreme environment, makes Mercury one of the most intriguing planets in our solar system. Its study continues to deepen our understanding of planetary mechanics and the diverse worlds that exist in our cosmic neighborhood.
The human body contains a surprising amount of iron, enough to create a small nail weighing about 2.5 to 3 grams. While this may seem like a trivial detail, it highlights the crucial role that iron plays in our biology and the intricate way the elements of the Earth are incorporated into living organisms. Iron is an essential element for life, playing a critical role in several physiological processes. The majority of the iron in the human body is found in hemoglobin, the protein in red blood cells responsible for transporting oxygen from the lungs to tissues and organs. Each hemoglobin molecule contains iron atoms that bind to oxygen, enabling efficient oxygen delivery. Iron is also a key component of myoglobin, a protein that supplies oxygen to muscles, and various enzymes that facilitate biochemical reactions essential for metabolism and DNA synthesis. Without sufficient iron, the body cannot produce enough healthy red blood cells, leading to conditions like anemia. The average adult human body contains about 3 to 4 grams of iron. While this might seem like a small amount, it is perfectly balanced to meet the body's needs. If you were to extract all the iron from an average body, it would be enough to forge a nail roughly 2.5 to 3 centimeters long. This striking comparison helps contextualize the presence of iron in our bodies relative to its industrial uses. The iron in our bodies has a cosmic origin. It was formed in the cores of massive stars through nuclear fusion and distributed across the universe during supernova explosions. Over billions of years, this iron became part of the Earth and eventually made its way into the food we eat, integrating into the cycle of life. Humans acquire iron through their diet, consuming it in two forms: heme iron, found in animal-based foods like red meat, poultry and fish, and non-heme iron, found in plant-based foods like beans, lentils, spinach and fortified cereals. The body absorbs heme iron more efficiently, but vitamin C can enhance the absorption of non-heme iron. A balanced diet is crucial to maintaining healthy iron levels. Iron deficiency is one of the most common nutritional disorders worldwide and can lead to symptoms like fatigue, weakness and impaired immune function. Conversely, excessive iron levels, often due to genetic conditions like hemochromatosis, can cause damage to organs such as the liver and heart. This underscores the importance of maintaining appropriate iron levels for overall health. The comparison between the iron in our bodies and a small nail underscores humanity's connection to the natural world and the elements that make up our universe. It also serves as a reminder of how minute quantities of certain elements can have a profound impact on life. The fact that there's enough iron in the human body to make a small nail is a fascinating intersection of biology, chemistry, and astronomy. This simple yet profound fact illustrates how our bodies are intricately designed to utilize the resources of the Earth and the stars for survival. It also highlights the incredible efficiency of nature, where even a small amount of iron can sustain vital processes critical to life.
The idea that a cockroach can live for weeks without its head is one of the most astonishing facts about these resilient insects. This peculiar ability highlights the unique biological systems of cockroaches and their remarkable capacity to survive under extreme conditions. However, while a headless cockroach can survive for a period of time, it ultimately succumbs to dehydration, not the loss of its head. Cockroaches possess several unique physiological traits that allow them to live without their heads. First, their nervous system independence. Unlike humans and other vertebrates, cockroaches have a decentralized nervous system. Their brains are not the sole control center of their bodies. Instead, ganglia, which are clusters of nerve cells located throughout their bodies, control basic functions like movement and reflexes. This means a cockroach can continue to move and respond to stimuli even after its head is removed. Next, minimal blood pressure cockroaches have an open circulatory system, meaning their blood, or hemolymph, is not confined to blood vessels. The absence of high blood pressure means that decapitation doesn't result in significant blood loss, as it would in humans or other animals. Lastly, a simple breathing mechanism. Cockroaches don't rely on their mouths or heads to breathe. Instead, they breathe through small openings called spiracles, located along their bodies. These spiracles allow oxygen to diffuse directly into their tissues, enabling them to survive without a head. Despite their remarkable ability to survive decapitation, cockroaches cannot live indefinitely without their heads. The primary reason they die is dehydration. The head houses the mouthparts and brain centers responsible for drinking and eating. Without a head, the cockroach cannot consume water, and dehydration typically kills it within 1 to 2 weeks. Evolutionary advantages. The ability to survive headless is a testament to the cockroach's evolutionary success. This resilience is part of what has allowed cockroaches to thrive for over 300 million years, surviving mass extinctions and adapting to a wide range of environments. Their durability has earned them a reputation as one of the hardiest creatures on Earth. Scientific and practical implications. The cockroach's ability to survive decapitation has fascinated scientists, prompting studies into their biology and nervous systems. This research has potential implications for understanding decentralized neural systems, which could inform advancements in robotics and artificial intelligence. Myths and misunderstandings. While the resilience of cockroaches is often exaggerated, such as the claim that they could survive a nuclear apocalypse, the fact that they can live without their heads is grounded in biological reality. However, the duration of their survival depends on environmental conditions and their access to water before decapitation. Conclusion. A cockroach's ability to live for weeks without its head is a remarkable demonstration of the resilience and adaptability of nature. This unique trait, driven by their decentralized nervous system, minimal blood pressure and independent breathing mechanism, underscores their status as one of the most durable creatures on Earth. While the thought of a headless cockroach may be unsettling, it serves as a reminder of the diverse and fascinating survival strategies found in the animal kingdom.
The phenomenon of a fungus taking over the bodies and controlling the movements of ants is one of the most extraordinary examples of parasitism in nature. This behavior is primarily associated with fungi from the genus Ophiocordyceps, particularly Ophiocordyceps unilateralis, often referred to as the zombie ant fungus. Found in tropical forests, this fungus exhibits a horrifyingly intricate life cycle that has fascinated scientists and the public alike. The life cycle of the zombie ant fungus. Infection. The fungus begins its life as microscopic spores that attach to the exoskeleton of an ant, usually from the genus Camponotus, commonly known as carpenter ants. The spore penetrates the ant's cuticle and begins to grow inside its body. Control of the host. Once inside, the fungus releases chemicals that affect the ant's central nervous system, effectively hijacking its behavior. The infected ant, now a zombie, exhibits uncharacteristic behaviors, such as leaving its colony and climbing vegetation to an optimal height for fungal growth. Death grip. In a macabre finale, the ant is compelled to bite down on a leaf twig or other substrate in what is known as a death grip. This anchors the ant in place and provides stability for the fungus as it grows and reproduces. After the ant dies, the fungus consumes the ant's tissues and eventually produces a fruiting body that sprouts from the ant's head or other body parts. This fruiting body releases spores into the environment, starting the cycle anew. The exact mechanisms by which the fungus manipulates the ant remain a topic of active research. Scientists believe that the fungus produces a cocktail of chemicals that interfere with the ant's neurological pathways and muscles. Recent studies suggest that the fungus does not directly invade the brain, but instead secretes compounds that control the ant's body, essentially turning it into a puppet. The relationship between Ophiocordyceps fungi and ants is a highly specialized form of parasitism. Each species of Ophiocordyceps often targets specific ant species, demonstrating a long evolutionary history. This specificity ensures that the fungus optimally manipulates its host to enhance its reproductive success. Despite its gruesome nature, the zombie ant fungus plays an important ecological role. By keeping ant populations in check, it helps maintain balance within forest ecosystems. Furthermore, its interactions with ants provide valuable insights into the complex relationships between parasites and hosts. The zombie ant fungus has become a subject of fascination for biologists studying parasitism, behavioral manipulation, and coevolution. Its ability to control behavior raises questions about the biochemical pathways involved, which could have implications for understanding similar mechanisms in other species or even diseases in humans. The idea of a mind-controlling fungus has captured public imagination and has inspired various works of fiction, including the popular video game and television series The Last of Us. These portrayals are often dramatized, but are rooted in the real-life horror of Ophiocordyceps. The zombie ant fungus is a chilling yet fascinating example of nature's ingenuity. Its ability to manipulate behavior, complete its life cycle, and maintain its role in the ecosystem underscores the complexity of parasitic relationships. While it may seem like something out of science fiction, this fungus is a stark reminder of the surprising and often unsettling strategies life on Earth employs to survive and thrive.
Uranus is one of the most unusual planets in our solar system because it rotates on its side. Unlike the other planets, which have axes that are roughly perpendicular to their orbital planes, Uranus has an axial tilt of about 98 degrees. This means that the planet essentially rolls along its orbit, creating unique seasonal and environmental conditions that set it apart from the rest of the solar system. Uranus's extreme axial tilt is unlike anything seen in the solar system. Most planets, including Earth, have a tilt that causes their poles to point slightly away from or toward the Sun as they orbit, creating seasons. However, Uranus's tilt is so extreme that its poles nearly lie in the plane of its orbit. During its 84-year journey around the Sun, each pole gets about 42 years of continuous sunlight, followed by 42 years of darkness. The exact reason for Uranus's unusual tilt remains a mystery, but the most widely accepted theory is that it was caused by a massive collision early in the planet's history. Scientists hypothesize that Uranus was struck by a planet-sized object, possibly as large as Earth or Mars, during the formation of the solar system. This impact likely knocked the planet onto its side, leaving it with its unique orientation. The extreme axial tilt has significant implications for Uranus's environment and seasons. Firstly, because of its sideways orientation, the Sun's position in Uranus's sky changes dramatically over the course of its year. For example, during the summer in one hemisphere, the Sun remains directly overhead at the pole for decades, while the other hemisphere experiences a prolonged winter night. Secondly, Uranus's magnetic field is also tilted relative to its rotational axis, making it significantly misaligned with the planet's center. This creates a lopsided and highly irregular magnetosphere that changes as the planet rotates. Lastly, despite its tilt, Uranus's temperature distribution across the planet is surprisingly uniform, with both poles and the equator being similarly cold. This is likely due to the efficient mixing of heat in its atmosphere. Uranus rotates quickly on its axis, completing one rotation approximately every 17 hours and 14 minutes. Its sideways orientation means that its equator rotates almost perpendicular to its orbital path. This rotation adds to the planet's oddity and contributes to its unique dynamics. The sideways rotation also affects the way Uranus appears from space. Its pale blue-green color, caused by methane in its atmosphere, gives it a serene look, but its rotation causes faint cloud bands and storms to appear in unusual patterns. Unlike planets like Jupiter and Saturn, Uranus's cloud activity is relatively subdued, possibly due to its frigid temperatures. The peculiar tilt of Uranus has made it a fascinating subject for astronomers. Understanding how the tilt affects its weather, magnetic field, and internal structure provides insights into planetary formation and evolution. NASA's Voyager 2 spacecraft, which flew by Uranus in 1986, remains the only mission to have studied the planet up close. But future missions are being considered to explore its unique properties further. Uranus's sideways rotation makes it one of the most intriguing planets in the solar system. Its extreme tilt, likely caused by a massive ancient collision, has shaped its seasons, magnetic field, and overall dynamics in ways that are entirely unique. While much about Uranus remains a mystery, its unusual characteristics continue to captivate scientists and highlight the incredible diversity of planets in our cosmic neighborhood.
The human brain is often described as one of the most complex and extraordinary structures in the known universe. One of its most astonishing features is the vast number of connections between neurons, which far exceeds the estimated number of stars in the Milky Way galaxy. This incredible connectivity is what enables the brain to perform its vast array of functions, from basic survival tasks to abstract thought and creativity. The human brain consists of approximately 86 billion neurons, the specialized cells that transmit information. Each neuron forms connections known as synapses with other neurons, creating an intricate network. On average, a single neuron can connect with thousands of others, resulting in an estimated 100 trillion synaptic connections in the human brain. Some estimates even suggest this number could reach as high as 1 quadrillion in particularly dense areas of the brain. These vast connections are what allow the brain to process and store information. Each synapse serves as a pathway for electrical or chemical signals, enabling communication between neurons. This communication is the foundation of everything the brain does, from regulating basic bodily functions like heartbeat and breathing, to enabling complex activities like language, memory, and problem-solving. The comparison between the brain's synaptic connections and the stars in the Milky Way is more than just a numerical analogy. Both systems are vast and intricate, operating on principles of interconnectedness. However, while the stars in the galaxy are primarily static, the brain's connections are dynamic. Synapses can strengthen, weaken, or even form anew, depending on the brain's activity and experiences. The brain's immense connectivity is what makes it capable of handling the complexity of human thought, emotion, and consciousness. It also underscores the challenges of studying the brain, as mapping and understanding such a vast network is a monumental task. Advanced technologies like functional MRI, optogenetics, and connectomics are helping scientists explore the brain's structure and function, but many mysteries remain. The comparison between the brain's connections and the stars also serves as a source of philosophical and scientific wonder. It highlights the idea that the universe is not only vast externally, but also internally within us. The brain's complexity rivals that of the cosmos, suggesting that understanding ourselves is as profound an endeavor as exploring the stars. The fact that the human brain has more connections than there are stars in the Milky Way is a testament to its unparalleled complexity and efficiency. This intricate network of synapses is the foundation of all human experience and capability, making the brain a true marvel of nature. As science continues to unlock the secrets of this incredible organ, it becomes clear that understanding the brain is key to understanding what it means to be human.
Sound is a mechanical wave that propagates through a medium by vibrating particles. Its speed depends on the properties of the medium, such as its density and elasticity. One fascinating fact about sound is that it travels about 15 times faster through steel than it does through air, illustrating how different materials influence the transmission of sound waves. In air at room temperature, around 20 degrees Celsius or 68 degrees Fahrenheit, sound travels at a speed of approximately 343 meters per second, which is 1,235 kilometers per hour or 767 miles per hour. In contrast, sound travels through steel at an astonishing speed of about 5,960 meters per second, which is 21,456 kilometers per hour or 13,334 miles per hour. This dramatic difference is due to the physical properties of steel compared to air. The speed of sound in a material is determined by two primary factors: elasticity or stiffness and density. Steel is much more elastic than air, meaning it resists deformation and returns to its original shape more efficiently when subjected to stress. This high elasticity allows sound waves to propagate more quickly. While steel is significantly denser than air, its elasticity compensates for this increased density, enabling faster transmission of sound waves. In simpler terms, the tightly packed atoms in steel transmit vibrations more efficiently than the loosely spaced molecules in air. The mathematical relationship governing sound speed, denoted as V in a medium, is given by the formula V equals the square root of E divided by Rho, where E is the material's modulus of elasticity and Rho is its density. Steel's high modulus of elasticity ensures a much higher sound velocity compared to air. The difference in sound speed has practical implications in various fields. Firstly, in engineering and construction, engineers use ultrasonic testing to detect cracks or defects in steel structures. The high speed of sound in steel allows for accurate measurements and diagnostics. Secondly, in seismology, understanding sound propagation in solid materials like steel helps scientists interpret seismic waves during earthquakes, as these waves travel through the Earth's crust and mantle at different speeds depending on the material. Lastly, in communication, submarine communication systems utilize steel cables to transmit signals efficiently over long distances, taking advantage of the faster sound speed in solid materials. While sound travels faster in steel, its perception changes. Steel transmits vibrations so quickly that sounds passing through it may lose fidelity or become distorted compared to those traveling through air. Additionally, the higher speed in steel often makes sounds less audible to the human ear because they don't dissipate in the same way as they do in air. Steel is not the fastest medium for sound transmission. Materials like diamond, which have even greater stiffness, allow sound to travel at speeds exceeding 12,000 meters per second. Conversely, Sound travels slower in less rigid materials like rubber or in highly compressible gases like helium. The fact that sound travels 15 times faster through steel than through air underscores the influence of a medium's physical properties on wave transmission. Steel's combination of high elasticity and density makes it an excellent conductor of sound. This phenomenon has numerous practical applications and serves as a reminder of how the fundamental principles of physics manifest in everyday materials and technologies.
Thank you for watching. We hope these mind-blowing facts left you amazed and inspired. Don't forget to like, subscribe and hit that notification bell because there's plenty more where that came from. Stay curious and we'll see you in the next one.